Hey everyone, thank you for joining us again for our next video as part of the Weather and Climate series. So if you've been following along this series in particular, we started off talking about the sun, seasons, latitude, intensity, and all that. But an important thing to discuss before we move on to the actual climate section is the water cycle. Now, you've probably heard about this since elementary school. It's sort of a staple in geography, social studies curricula, so you're probably already somewhat familiar with this, but it's still nonetheless important to cover, especially as we begin our climate discussion next. So, just to start off with, what is a water cycle? So, the water cycle basically indicates that water continuously circulates through the atmosphere, through the ground, underground, and in different forms, right? So we have, as we all know, water exists in three states: solid, liquid, and vapor. Obviously, solid water is what we refer to as ice. Now, most of Earth's fresh water is ice, which is locked in these massive glaciers, ice sheets, and ice caps. About 70% of the Earth's water is stored as ice in polar and mountain regions. Now, once the ice melts due to heat from the sun or heat in general, it turns to liquid. The oceans, lakes, rivers, and underground aquifers, they all hold our liquid water. So approximately 30% of liquid water is found under the surface as part of groundwater, with around 1% in rivers and lakes. And in its gaseous phase, water is water vapor. It's not evenly distributed across the atmosphere. Above the ocean, water vapor tends to be more prevalent, making up about 4% of the air. Above drier areas, like deserts, can be less than 1% of the air. So in terms of the actual processes of water changing states, we can begin with by looking at the diagram. The diagram is pretty intuitive in showing the flow of water, but just to explain some of the main phases. First is evaporation. That's a process whereby liquid water changes to a gas. Basically, from heat, water evaporates from oceans, lakes, and streams. Basically enters the air as water vapor. It's an important greenhouse gas, water vapor. And greenhouse gases like water vapor, carbon dioxide, and methane, they're important for insulating the earth and keeping the planet warm enough to maintain life. Obviously, increasing amounts of greenhouse gases in the atmosphere are contributing to global warming, but it's important to note that water vapor is technically a greenhouse gas. And yeah, the water cycle's evaporation process is pretty much driven by the sun, and the rates of evaporation are typically influenced by wind, temperature, and the density of the body of water. So if you remember in our earlier video, we discussed how warmer and saline water tends to be less dense than colder water. And so, so evaporation is also affected by the characteristics of the water underneath the oceans and lakes and rivers. Then our next phase is condensation, which is the process of a gas changing to a liquid. Basically, in the water cycle, water vapor in the atmosphere condenses, becomes liquid. Condensation can happen pretty high in the atmosphere or even at ground level. So clouds that form as water vapor condense, become denser, and basically water vapor condenses around these tiny particles, things like dust, salt, or pollutants. Basically, that forms clouds. And clouds at ground level is what we refer to as fog or mist. Similarly to evaporation, condensation is affected by the sun. As water vapor cools, it reaches what we call the dew point, and once it hits that dew point, the water vapor will condense into gas. Next, we have precipitation. Precipitation basically just describes any liquid or solid water, so either rain, snow, or hail that falls as a result of condensation in the atmosphere. It's important to note that fog isn't precipitation, so the water in fog doesn't condense enough to precipitate or liquefy, and so fog and mist are in kind of their own category of suspensions. They're basically liquid water suspended in the atmosphere. But as we know, with precipitation, that also depends pretty heavily on the temperature in the atmosphere. So basically those three processes, evaporation, condensation, and precipitation, are sort of the three, I'd say, most important ones to recognize when it comes to learning or understanding the water cycle. But there are other processes as well, as the diagram shows. So first, talking about runoff. Basically, runoff is another way in which solid water turns into liquid water as part of the water cycle. For example, snowmelt. So snowmelt from glaciers or mountains. Once it gets warm enough in the spring and summertime, it will liquefy and run into streams or pools or form those things. So it's an important one to remember. Another important part of the water cycle is transpiration. Basically, this is the process of water vapor being released from the plants and soil. So plants release water vapor through their own mechanisms, which are influenced by light. And so, transpiration is basically evaporation from living organisms, essentially. And usually we group them together with evaporation and combine it to be called evapotranspiration. And that's pretty much it for the basics of the water cycle. Our next video will discuss climate.